Let's look at number three. Well, there are a couple of different ways to explain this one, but I would like to explain with the useful way for your calculus course in A&M. Okay, so well, let me give you one important property. Okay, so maybe some of you know about this one. Let me write it on the side. Okay, so basically, whenever you have exponential function with logarithmic exponent, then this array is happen. Okay, look at that. So let's say a to the log of ax is equal to x. So how can I explain this one? It can be like this way, okay? If your base of exponent is a and base of logarithmic function is a, then we can just like simply think as the cancellation. Like whenever you have exponential function with base a and you're on your exponent, you have the like logarithmic function with base same base a, then you can just simply cancel out, then you're gonna have x only. Is that clear? But the main important thing, mainly like most important thing is your base of exponential function and logarithmic function must be same. Is that clear? Okay. So I'm going to use this property for hold this number three problems. Okay. So please keep that in mind. Okay. So look at the problem A. Okay. On your left hand side, log of 2 of 8 is equal to 3, right? So look at that. You have like a base 2 for your logarithmic function. Then we're going to raise 2 on both sides as the exponential function. I mean, we're going to put 2 here and 2 here. Then as I explained, and this 2 to the log of 2 will cancel out, and your left-hand side is 8. Then this one can be written by 8 is equal to cubed. That's obvious, right? But this is the way to change your logarithmic expression as the exponential form. Is that clear? Okay. What about B? Oh, like when you look at the log, the given log, the base is invisible, right? But we know the like name of this logarithm function, right? It is common log, which means base is 10. Like it is like invisible, but like there's 10. So we're gonna raise 10 on both sides. Then as we did before, we can consider like this way. So your left hand side is 100. It is 10 squared. Is that clear? Okay. What about C? We will do the same thing. When you check the base of log is 4. Then we're gonna raise 4 on both sides. Then for this case on your right hand side, then we can write as the exponential 4. Okay. 4 cubed is 64. Okay. What about D? That is ln. The name of this logarithm function is natural log, base e, right? So irrational number e is the base of this, okay? So we can raise e on both sides. Then, as we did before, that happened. The left-hand side is just 1 e to 0. As I explained in the previous problem, any number, non-zero number to the 0 is always equal to 1, right? That is true, okay? And we will keep doing the same thing, okay? Here we go. Raise 6 as the exponential function. Then that always happen. Then left-hand side is 216, which is equal to 6 cubed, right? What about f? Like again, like the purpose of this problem is not solving the problem, but I mean, like is the purpose of this problem is not solving not solving the equation, but we're gonna change the format as the exponential equation, right? So even the base is not fixed number, but it's b, right? So we will do same thing, okay? Raise b as an exponential function, then that always happen. B to the y is x, right? What about 3? Base is 5, right? Then on the right-hand side, that always happen. Then this can be written by 5 to the negative 2 is equal to 1 over 25. That's very true, right? And we have a couple more. There we go. Keep doing the same thing, okay? 7 and 7. Then that always happen. Then this one can be written by 1 is equal to 7 to the 0. That's very true, right? And I, base is 9. Then we're going to make the exponential function with 9, base 9. And that happened. Then x is equal to 9 to the y, okay? It is still equation, but like we don't have to solve the problem. Actually, there is no way to solve the problem, but like we would like to change the format, okay? And what about J? Same thing, raise 4, okay? And it is gone. Left hand side is 4 to the 3 half, which is equal to definitely 8. And K, natural log, right? Base E, right? And cancel out. E to the Y is X, right? And then L, again, we are not going to try to solve it, okay? The solving the logarithmic equation is next problem. We can talk about that one later, okay? But anyway, we're going to just try to change the format. This case, base is 3, so we're going to raise 3, and this is gone. And on your left-hand side, you have x squared minus 3x minus 1 is 3 squared, right? And to do the same thing for M, raise E on both sides because that is the natural log. Then E to the log will be gone, and E to the 5 is x minus 7.